In section 5.1, we're going to learn the basic properties of rational expressions and reducing them to the lowest terms. So, we're going to learn how to simplify, multiply, and eventually divide rational expressions. And how do we do this? Anyway, what is a rational expression? Well, a rational expression is an expression of a form that's kind of like a fraction, where you have something in a numerator and something in a denominator, whether it be a polynomials over polynomials, or binomials over binomials, or just letters. So by definition, if P, Q, and R are polynomials and Q and R are not zero, because we don't want anything in zero to be at the bottom, because that will make it undefined, we define a rational expression this way. And that's based on the idea of rational numbers. So in order to do this, what we're going to do, we must first factor the numerator and denominator as needed, and then cancel out the factors. We cannot do that before. So for example, if we have something like this, well, we can't just cancel things out, because we have we have subtraction here and here. So what we have to do is we have to factor this as the difference of two squares. So we do that. And here we go. And here we x plus 3, x minus 3 over x minus 3. And now we can cancel out the x minus 3's to get x plus 3. So the numerator and denominator have the factor x minus 3 in common. And when we divide, when we cancel this, it's equal to 1. So x plus 3 times 1 is equal to x plus 3. So the bottom line is you cannot cancel out terms that are being added or subtracted, meaning you cannot start reducing based on 9 and 3. Or do something like this. Because every time you do this, and a lot of people do this, they're tempted to do this, is cancel this out. Oh, I see an x squared, I see an x squared. I'm going to cancel that out. But because here this is added and this is added, so every time you do this, a kitten dies, and you don't want to kill kittens. So let's look at example number 2. So here we have this expression, and we're going to factor the top part, and we're going to factor the bottom part, which is the difference of two squares, and factor the top part. And we see the y plus 1 and the y plus 1 cancel, so we can get a y minus 6. Now in this next one, it's a little bit different. So we see 4 terms here. So when you see something with 4 terms, think it's perhaps factoring by grouping. So let's try that and see what happens. So I'm going to factor these two by grouping. So the top here's my first group, and I'm going to pull out the x, and I get x times x minus 3. And in the second term in the numerator, I pull out the a, and I get x minus 3. A times x minus 3. And similarly in the denominator, where I pull out the x, and then I pull out the negative 3. And then, of course, I factor the way I would factor by grouping. So I have x minus 3 in common, and then I put the leftovers in the other bracket. And then I have x minus a in common, and then the leftovers in the other bracket. And I notice that x minus 3 and the x minus 3 cancel, so I get x plus a, x minus a. So now let's look at example 4. And And we're going to reduce this to lowest terms. And one may look at this and say, oh, but we have the same letters, therefore they're the same. But they're not, because this A is a positive, and this A is a negative, and this B is a positive, and this B is a negative. So, and then you may say, well, since that is true, we can't reduce it. But yes, we can. Because we can see that if we pull out from here a -1, we'll get negative, and then bracket, negative A plus B. So that means they're opposites. So we factor out the -1, and just like I said, here we get a negative A plus B on the top, and there we have the B minus A. Now we can rearrange this because this is commutative, and we can rearrange it so we can put the B here minus A, and then we can have the B minus A over here and the B minus A down here, and it turns out that the B minus A's cancel out and we get just -1. This is a very important trick to know because this comes up a lot, and it may come up a lot on your certification exams too. So let's look at example number 5. And here we want to reduce this to lowest terms. Now again, as I said before, we want to factor first. We don't want to start canceling things out before we factor, because that's a no-no. We don't want to kill any kittens. So what I'm going to do is I'm going to factor the top, because it's a difference of 2 squares. And there I have it for the difference of 2 squares. And then I see on the bottom here, we're going to have to use our little trick, because on the bottom we have a plus 5 and a negative x, and that doesn't correspond to any of these. And you say, oh, well, we're finished. But no, we are not, because we can factor out the -1 here to get down here to get -1 times x minus 5, like I said earlier. So 5 minus x, pulling out the -1, we get -5 plus x, and then rearranging it, we get -1 x minus 5, using the trick that I just showed you in example number 4. So here we go, and there I did that. I used the little trick down here, and you notice now we can start canceling because we realize that these two are the same, and then we get as our final answer x plus 5 over -1, which is the same thing as saying -x plus 5. In example number 6, we're going to look at this expression. As you see, here we have trinomial on top and a trinomial on bottom. So we want to factor those two. So we factor the top and the bottom to see if anything cancels out. And indeed, we have the x plus 4 cancels. And then we have that as our final answer, x minus 1 over x minus 5. And here in example 7, we simplify this. Now notice we're going to use the same trick here that we used in example 4 and 5, because we see that they have the same letters and numbers but opposite signs. So we're going to pull out a -1 on the top and rearrange it. So there we pull out the -1 and rearrange it so we get both the top and the bottom are the same. And that means they become 1 when they cancel. And our final answer is -1, because it's -1 times 1 will give you -1. Because when you cancel out, what you're essentially making is a 1. You're multiplying whatever it is by 1. Well, thank you very much, and stay well, and I hope you enjoyed this video. and take care, and bye.